Okay, this equation right here is graphed right here. I want to find its focus in directrix. This equation, since it's x equals, it's going to open left or right. Horizontally is left or right. Now, because your a value is negative, it's open to the negative side. If it was positive a value, it opened to the right side, the positive side. If you look at this problem right here, since it's y equals, it opens up or down, and since a is positive, it's opening up. So basically, anytime you have y equals, it's either up or down, vertical, and whatever the a value tells you which direction. If it's x equals, it's left or right, and whatever the a value is tells you which direction. Now, besides that, for quick sketches, we also want to think about what the focus in directrix is and plot those and graph those and calculate them and so forth. Okay, to find the focus, I want to find out there's a focus somewhere inside of this parabola. There's a focus somewhere inside of this parabola. It's a dot. It's a focal point. It's important for, there's a lot of properties related to it. So if I want to find the focal point, I want to find C. Call that the focal point. And there's a formula right here. So to find the focus, it's going to be C equals 1 over 4 times A. Now what's A? Well, look right there. It's negative 1/8. So A, for this particular problem, is negative 1/8. Okay, let's do the math. Let's see, this would be 1 over, can I put an over 1 real quick right there? For some of you that might make more sense. What's 4 times negative 1? Is that negative 4? And what's 1 times 8? Isn't that 8? So what's 1 divided by negative 4/8? Isn't that 1 divided by negative 1/2? Wouldn't that be negative 2? So our answer is negative 2. So for our coordinate here, do you see how your C value? Our focus is going to be 2 values over, right there. Because the focus is inside, and that coordinate, isn't it negative 2, 0? Isn't your C going to go into the x value since it's going left to right? And that's always going to be 0 because it's starting here at 0, 0. Now, once we know that, how do you find your directrix? Well, what your directrix is, it's a line. You don't even know what it is yet. But this is your focal point. Makes a lot of sense. The directrix is going to be x equals, what's the opposite of negative 2? Positive 2. So what I do is I plot x equals negative 2. Well, if I go over here, 2, that's 2. And the graph x equals 2 is a vertical line. This is the graph x equals 2. So this is your focus, this is your directrix. We completed this. Now, there's one interesting property I'm going to talk about that deal with parabolas. There's an interesting property. You don't have to write this on your notes unless you want to, but what's useful about the directrix is as follows. If I go straight from here to the graph and find a point on the graph, if I make a straight line from my focus to the graph, what's that length? Isn't that length 4? And then go from there straight to the directrix, what do you notice about the lengths? They're the same. If I was to go, like, say, from here to right there, I found a point. I just went straight to the graph. And I went from that point straight to this line. What do you notice about those lengths? They are the same. I'm going to use a geometric term of just dashes. So what's interesting about the directrix is the length from your focus to the graph and the graph straight to the directrix is always the same. It's a property that, it's a way to kind of check to see if your parabola looks right. You can quickly kind of check how accurate is my parabola by making points and going, how far is it from here to here, and then from here to here. You can check your parabola. It's not something you're ever going to be tested on, but it's a good way to make sure your parabola is making sense. We'll do it again on this one. All right, let's do this one now. Let's find C. So C is going to be 1 over 4 times A. And what's A? A is 2. So C is equal to 1 over 8. Oh, how the heck do you go 1/8 up? Well, just kind of, is that pretty small? 1/8, let's just kind of put it right there. I mean, you got to find a spot for it. That's about 1/2. But are you okay with 1/8 is barely, you can't really draw it with my graph. But are you okay with it going up 1/8? So this coordinate, isn't it 0C? So isn't this going to be 0, 1/8? Isn't that the coordinate of that focus? So what would the directrix be? The opposite of 1/8, which would be negative 1/8. And it's y equals, because watch, from this point, don't we go down 1/8? And then make a line? You guys okay with that? That's y equals negative 1/8 is the graph of that. So, we have our directrix and our focus. It's really, sometimes your focus and directrix are very small. It would have been better for my graph to be in like increments of like half. It probably would have been better if I zoomed in on my graph, but I didn't. Now, last thing. Let's do this directrix thing. If I take a point, say I take from here to there, the length from here to there, and from there to there, if I drew it properly, these would be the same. Now, is my focus right where it should be? No. But these two lengths, if everything's drawn properly, should be the same. Again, because I can't find my focus and directrix very good because they're so small, it's not perfect, but these two lengths will always be the same. One more thing. Do you notice how here your focus is 2 lengths away, and here it's 1/8? What you'll notice is, the farther your focus is from the vertex, do you see how wide your graph gets? The closer your vertex gets to the, the closer your focus gets to the vertex, do you notice how your graph narrows? So the narrower your graph, the closer the focus is to the vertex. The wider your graph, the focus is farther out.